Alright, today's video is on power functions and function operations. Our goal is to perform operations of functions and analyze the domain. Now make sure you write down any questions you have as you watch this video. Alright, so if you have questions in class, you can remember them. Alright, example 1. Let f of x equal 4x to the 1/3 and g of x equal x to the half. We're going to find a the product, b the quotient, and c we're going to state the domains. Alright, now before I get going on this, I want to remind us, and I'm going to rewrite this. G of x could be written as, instead of x to the 1/2, that's like the square root of x. So there's a little 2 here in this spot that we don't write. I could go ahead and write it this time. Alright, and then for f of x, I don't have a lot of room here, so I'm going to go ahead and write it over here. For f of x, we'll just put an arrow over here. This is the same as 4 times the cubed root of x. So we have to get used to writing those. And that's a little cubed root. Let me make sure I write that more clear. So that's a little 3 right there. Alright, so now when we're dealing with domain, it's a lot easier to deal with these types of equations in their radical form, alright, or the root form, instead of looking at them as fractional exponents. Now, we're going to do some operations here in a second, but to help us out, if I was to look at the domain of this is something where if I take the square root of numbers, we know we cannot have anything negative. So the domain of just this little piece would be x greater than or equal to 0. Now I'm not finding the domains of my answer yet. I'm just kind of doing some side work here. Now, because it's a square root, I can't take the square root of negative. So that's what x is greater than or equal to 0 means. If I'm taking the cubed root, I can take the cubed root of negatives, zeros, or positives, and so the domain of this is all reals. Now, I'm going to write this funny looking R. That means all reals. Alright? Now, the two things we're really concerned about when it comes to domain, I'm going to kind of do a little statement up here, is if I have something like 1 over x, then x can't be 0. I can never allow denominators equal to 0. The other thing I have to worry about is the square root, or actually, let me just put e here. And I put e there if that is an even number. So the even root of some x has to be greater than or equal to 0. I can't take the even root, or the square root, 4th root, 6th root, and so on, of any negative numbers. Those are the two things we're worried about here. So in this problem right here, this piece right here, the 3 is odd. And so I can put all reals into that, where here this 2 is even, which means I have to have all positives, including 0. All right, let's go ahead and do the algebra on this problem, and then state the domain at the very end. All right, so A. Now, if we're finding the product, that just means take f of x and multiply it by g of x. So f of x. Now I'm going to go ahead and write this in rational exponent form, or I'm going to just keep these as fractions. So it's going to be 4x to the 1/3 times x to the 1/2. That's all this is telling me to do, multiply f of x times g of x. Now, in order to add these exponents, remember if bases are the same, and I'm going to write this next step, we keep the base is the same when we multiply and we add the exponents. So this is really telling us to have 1/3 plus 1/2 as an exponent. Alright, now in this problem we have 1/3 plus 1/2. We need a common denominator to add those fractions together. Now I'm going to let you do this in your calculator. So what you're really going to do real quick is 1 divided by 3 plus 1 divided by 2, enter, and then hit math fraction. Right, we should all know how to do that. And so I'm going to end up with 4x. I should really put equal signs over here. Sorry about that. So we're going to end up with 4x. 1/3 plus 1/2 in your calculator is going to give you 5/6. So I'm going to have 4x to the 5 over 6. All right, now I'm going to go ahead and state the domain, but this is the answer to the product. So I'll circle this. So that gives me the product. I can write the domain over here. So domain. All right, now, before we talked about domain a little bit, and I will highlight the little pieces we talked about. For this part, the domain is all reals, and for this part, the domain is x is going to be greater than or equal to 0. When I multiply these two together, I really just multiplied this times this. So the domain, really, I could look at this step right here and realize, I'll just put like this little arrow here, 4 times the cubed root of x times the square root of x. The domain of that is just going to be the domains put together of the individual pieces. And so it's going to be all reals. So we'll do this funny looking R again, where x has to be greater than or equal to 0. So really all I did is put the two domain pieces together from each function that I multiplied together. All right, so for part B, it says find the quotient. Now, when we find the quotient, so B right here is just going to be f of x divided by g of x. Now, remember a while ago I said we have to watch out for denominators. So now, really what we do here in this problem is we create a situation we didn't have before. We really didn't have a denominator, and now we're going to. So let's go ahead and place f of x in the numerator. Again, I'm going to leave this 4x to the 1/3. And let's divide that by g of x, which is x to the half. Now, here, when we divide bases that are like, we have to subtract the exponents. So instead of adding in the last problem, we're going to subtract these exponents here. So what's going to happen is, I'm going to rewrite this as, again, I should write equal sign. This is really going to be 4x to the 1/3 minus 1/2. And you can do this 1/3 minus 1/2 in your calculator. And what you'll get is 4x to the -1/6. All right, now we know we can't leave negative exponents like this. So over here, I'll write a little more. I'm going to write this as 4 over. This x will come down to the denominator, so the exponent can become positive 1/6. Now this is your final answer of f of x divided by g of x. All right, now we still have to do the domain. So domain. Now in the last problem I multiplied the two together and I just put the two domains together. I'm going to do the same thing here when I do the domain. All right, really, I can go ahead and highlight this also. I'm looking at this step right here, right? So in this step, and I can go over here and kind of put an arrow, I'm looking at the domain. So I have all reals in the numerator. I can put everything in there I want from this right here. But in the denominator, I have to go look at this spot. Now, x can't be negative, but not only that, now because it's in the denominator, it can't be 0. And so this is a little more tricky. This goes to all reals. But x has to be greater than 0. And so I can't allow x to be 0. So the difference here is we lost the ability to use 0. Right, now example 2, we're going to let f of x equal 2x to the -1, g of x equal x squared minus 1. Find the following and state the domain. Now here we're going to do composition of functions. But I'm going to rewrite this again because I like to write this as an easier form. I'm going to write this as 2 over x. All right, I'm going to bring the x down and make the exponent on that a positive 1. This doesn't need rewritten. Now what this allows me to do is look at this real quick and say that the domain, I can't allow x to be 0. And on this one, my domain would be all reals. On this one, it's just a nice polynomial. I don't have any denominators, and I don't have any roots that have an even index or an even number up in that little corner. All right, so now let's go ahead and find f of g of x. So this is going to be equal to f of, this is just substitution. It says in the inside to put g of x, so that's what g of x is. So right here, I have g of x, and this is g of x right here. So I'm going to go ahead and put g of x inside here. And so this is going to be x squared minus 1. Now, I have to think of the domain right away. Right? There's two spots with compositions that I have to deal with domain. Right now, if I tried to put numbers into this function, I'd have to try to, I'm really going to try to put numbers into here, into that x, right? And so that's just a little arrow. So right here, let me fix that a little bit. So right now, I'm going to put D for domain here. I'm thinking of domain. Because, again, over here I said my domain's all reals, I don't have anything to worry about yet. So I'm going to continue on with the problem. So now this next step, though, tells me to take g of x and put it into f wherever I have an x. And so let me highlight that. I want to go to x, which is here, but I rewrote it as this. And I want to put this in for that highlighted x. So it's just another substitution. And so for this part, this is equal to 2 over x squared minus 1. This entire piece goes in for x, which is here. All right, now this is actually done for f of g of x. But I still have to worry about domain. So this was the answer for f of g of x, but now the domain here, I'm going to put a little arrow. I can't allow that bottom part, x squared minus 1, to be 0 because it's in the denominator. So I have to do some work for the denominator or the domain. So domain, I know that x squared minus 1 is not allowed to be 0, or it's not equal to 0. Solve this just like any other equation. Add 1 to both sides, and I'm going to get 1. And then I can plus or minus square root both sides. Don't forget when you square root to plus or minus. So x is going to be not equal to plus or minus 1 when I square root both sides. So my domain answer finally is going to be all reals except the plus or minus 1. All right, I'm going to skip down to C, and then tomorrow we will finish these notes for you in class. You're welcome to try them on your own, but again, we'll finish them for you just to go through it again. All right, now f of x, this is going to be f of x is the function right here. It's 2 over x. So I'm just substituting 2 over x for f of x. Now right away I'm going to deal with the domain like I did up there. I'm going to put a little d here. Now I can't allow that denominator to be 0. In this one, if I do some work, I really would just do this. X can't be equal to 0, and there's nothing to solve like there was in this problem. So now my domain I can actually write right away. It's going to be all reals except 0. Now I may have to add to this in my next step when I do my domain for the second part. So let me scroll this up a little bit. All right, now I'm going to take 2 over x and put it back into f of x in for x. So really now the next step is to take 2 over, now f of x used to just have an x here, but I'm going to take all of this and now put it into itself really. So I just took 2 over x and replaced it with x. Now we have to simplify this, and I'm kind of running out of room down here, so I'm just going to write the next step right here, which is fine. So I'm going to take 2. Now this is really all one part of it. Divided by 2 over x is like multiplying by x over 2, which is the reciprocal. So dividing by 2 over x is like taking 2 and multiplying it by x over 2. The 2's cancel, and the answer to this is just x. So this is f of x. Now, I will look at the domain again here. So I'll put a little d here if you wish. And since this piece here looks like it's all reals, I don't go ahead and write it again. I also have to keep that x can't be 0. This is a little strange. This is why you have to do domain in steps in these problems. Do not wait till the end until after you simplify. So in this case, the not equal to 0 comes from this part up here, then it got multiplied by the reciprocal, so it looks a little strange. All right. Sorry for a very difficult topic. Composition of function with domains is tough. See you in class.